This video will cover the design of the outer ring of the steering mechanism. Now, like other parts of the robot, I'm using as much of what I have on hand as possible. That of course means I'm going to be using the 10.5-inch wide by 0.89 inch thick aluminum plates to machine everything I can. But I also happen to have some 1.25 inch diameter Delrin, and these will be used for the wheels that couple the inner and outer rings. This is the core piece of the outer ring. This is where the motors get mounted and the gearing transfers the torque from the motors through a chain to the inner wheel steering mechanism. Now here is a problem that I really don't have a solution for, and it's a structural problem relative to strength. Because the plate is only 10.5 inches wide, there's not enough room to have 2 bolt interfaces per side. Essentially, on this side over here, you have 2 bolts passing through to give you reasonable bending strength through this position. A single bolt, it's going to be very weak. I can guarantee you if the system takes a very large vertical shock, it's going to bend right at this interface. This is the next lower piece, and you can see the double bolt locks these two together, and you have reasonable good transfer of load through there. And on this side, not so much. Above, below, and that completes the ring part of the outer ring. Each of these pieces will be machined from the 0.89 plates. Like the inner ring, they can be nested for efficiency and minimum material loss. Sitting in these gaps, you have, in the inner part, this is a captured pin, 1/4 inch diameter, plenty of load capability. So those pins run in each of 15 locations. Nominally they're 16, but at this point here we're going to have our brushes, so that removed the 16th location. The Delrin wheel, 1.25 inch. Notice that it doesn't really stick out much, but it doesn't have to. You want to keep it as the 2 rings as close to the same size as possible to maximize the shear load capacity. The shape of this wheel fits into the notch in the inner ring. This system is built around a fully assembled internal ring. Once it's assembled, the 2 are locked together, and you cannot get them apart unless you completely disassemble the outer ring. The idea is that I'll build up spare sets, and we'll have them on hand if I need to swap them out. Now let's look at the steering drive. I don't have these motors yet. These are 6354s. I don't know if I'm going to have the weight to run 2 motors at once. In some cases it might be more favorable if I end up going just one steering motor. It might be more favorable to have it on the left side or the right side, depending on where the wiring's coming from. So right now the design handles two, as if we can do it in the long run weight-wise, that would be best. If the system's drive goes down, we can still survive as long as, you know, two or even one wheel still has drive. We can still keep going. Once the steering starts going down, the system will go down in a hurry. It'll be very difficult to drive this thing if you can't steer the individual wheels. As same as before, these are 15-tooth 1.5 module gears. And you'll see there's a very similar, I try and keep things with as many parts as possible that share the same size and same redundancy, so it minimizes the different number of parts I have to spare. This is the same type of design as the drive. It's got a clutch system in it with internal springs. The big difference is the output of this is this 16-tooth gear. This cover I'm going to make of Delrin. I happen to have some chunks of Delrin that are the right size. It doesn't carry that much weight. It makes me be able to tuck this in tightly to the gear and let the chain rub on it. If it's Delrin, it's not going to care that much, and allows for a mount, an easy mount for the encoder. There are 3 locations here. I don't know if I'm going to use 1 or 2 of them for the optical sensors for the home position. If I go with spares on everything, it seems to me I need a spare optical sensor. These are mounts for the wire rope isolators. I would have loved to have these aluminum pieces cover the gaps, but it just doesn't work that way because of the missing spots here. This missing spot where the brushes go means I had to tuck this in as tight as possible here to keep the system symmetric. Each of those isolator mounts has a wire rope isolator on it. I'm hoping this helps the system survive, because this isolator will limit the amount of shock that the wheel can take. Ideally, if you land and the wheel can compress some, the frame can bottom out, and bottoming out the frame limits the maximum load into the wheel. That's the theory anyway. There are little steel, basically caps, that I want to put over the gaps to help stiffen them for carrying load. And I put them where possible. It's not always, once you see how this assembly comes through, it's not possible to have them at every location. There's our 4 wire rope isolators. To get power across the gap, there is a brush assembly. Nominally, it's 3D printed. I could make it out of Delrin in multiple pieces. It's just going to be rather difficult. Each of these 3 brushes, so the 3 on the top carry the positive and the 3 on the bottom carry the negative. 3 brushes means that if one bounces and comes off a contact, that I don't lose current carrying capacity. These encoders, it turns out that I had 9 very, very expensive encoders that I got off of eBay many years ago, at least 8 years ago. They are something on the order of 8192 counts per rev, and they're pretty structurally sound. Again, if we go full redundancy on the steering, there's a place for the encoder on the top and there's a place for the encoder on the bottom. If I only end up going with one encoder, obviously I would cut the one that sticks out. It's the most susceptible to damage. This will either be Delrin, or if I run out of time, I'll probably 3D print it. This is a chain tensioner. So the idea is that you set up the chain to be as close as possible, and then as the chain wears in, this can be stepped in one at a time. If in an individual step is too coarse, then I should be able to 3D print like a half step pair of these. I don't know if I'll have to do that. This whole system is supposed to run loose, right? It's not like everything on the robot. It's not designed to run for 10 years. The lifetime of most things on this robot is probably less than 20 minutes. So you really don't have to worry about your gears being perfectly tight, and in this case, these Delrin wheels, you don't want them tight in on the inners, because a little bending, a little damage, and they could bind. Make everything really loose. AK-47 design is what they call it. Finally, the last piece of the puzzle. That's the interface plate. Now that design grew out of the center core, the center hex design, and I'll show that in the next video.